Okay, my name is Rachel Wrublik. I'm a mechanical engineer with PAE. So quick agenda. I do have a number of slides on the case study, so I'll probably touch on that pretty high level, go through that quickly. To kick it off, I'd like to step back and look at emissions by sector. This data is from Project Drawdown, and I just like it because it does show this figure on the left. Industry counts for 21% of emissions, but then when we look at the electricity production, which is 25%, you break that out, the figure on the right, and you can see electricity used in an industry is another 11%. So combined, we've got our manufacturing, industry, material world production accounting for 30%, over 30% of our emissions. So it's a large impact. Obviously, you know, where the built environment's just a portion of that. So then diving back into MEP materials, this has already been touched on a little bit, but there's a lot of high impact materials in MEP, so a lot of metals, electronics. The equipment often has many parts and pieces. This makes it difficult to track, difficult for the manufacturers to actually do an EPD, a full LCA, because of all those pieces. And then there's issues around actually being able to recycle and try to come up with a circular economy. So then this is an office building case study. We looked at the LCA just on the MEP, and I guess we also did on the full building, but we dived into the MEP on this one. And figure on the left shows the breakout for elements, mechanicals the highest, which is typically the case. It's, I think, similar to what we see in the architectural and structural, those items that weigh the most often have the largest impact, or the low-hanging fruit. So in this case, mechanical is the top, and then electrical, followed by plumbing and fire protection. If we look at that in comparison to the whole building, MEP systems accounted for 23% of upfront emissions. And then this 6% here is interiors. So, you know, we're looking at roughly 30% for this, for elements that we traditionally have not been looking at. And in this case, this building's already been somewhat optimized. It's a wood structure, so structural has been reduced, so then what's happening is we have this other piece of the pie that we're just not accounting for and not optimizing it. Diving to the mechanical systems, you can see the heavy hitters here. Ductwork was brought up earlier. Equipment can be, these are the bottom ones here are the heavy, large equipment rooftop. And you can see the breakout here. In this case, a lot of the ductwork has been minimized, actually in some cases using wood as ductwork. So you can see the large footprint here of the equipment. And then looking at that over time, this is a 75-year life cycle. You can see the equipment here at the bottom as that's replaced. So, and this is looking really at just the A1 to A3 impacts and then replacement over time and not end of life. So, I mean, a lot of the MEP equipment does need to be replaced through the building's life cycle. And then the other elements, this was based off of ASHRAE's standard lifespans, but then there's also the added impact of potential TIs and replacement there. Moving on to plumbing and fire protection, you can see piping being this cast iron piping that was mentioned earlier being a large impact. And you can see it over time as same 75-year life cycle increases. In this case, we were looking at the difference of going from cast iron to PVC, so switching out materials, and on the domestic water piping, switching from copper to PEX. These do offer lower global warming potential, but then there's some pretty heavy trade-offs in that there's some environmental and health concerns associated with these products, and closed-loop recycling chains do not exist. Moving on to electrical systems, in this case, I am including PV. This was an array was being considered, so it is a large impact, along with lighting, transformers. And then you can see at the bottom graph this over time. With lighting is this one that gets replaced fairly frequently and has an initial high impact. Okay, so then diving in a little bit on the PV side, here's a comparison of electrical with the PV and without, and it's a 22% increase in the electrical embodied emissions right up front, which seems large, but if you look at the offset, the emissions offset annually from the PV based off of the local utility emissions, you can see, it's offsetting each year. If we look at that over time on the right, you can see that somewhere in year 3, it pays back itself. It offsets all of its embodied emissions and then becomes carbon negative. And of course, this is going to vary depending on the grid. Speaks to, with MEP, we've always been focused on energy. Here, we're coming to a point where we need to optimize operational and embodied emissions and really think like what's going to happen in the future with the grid. So this is just a quick look at 75 years, all of them stacked together. Mechanical still is the largest there, and you can see PV is the yellow at the top. All right, then here you can see the whole building. So this is the structural and architectural and interiors, and then the lighter blue is MEP, and then the yellow here is adding that PV array. So it adds about 2% to the total up front, but then you can see over the course of time, it can provide operational offsets. So this is and we've got quite a range there. This is based off of depending on what happens with the grid. So some uncertainty there and a bigger discussion for maybe another time. All right, so then if we break it out by module A to D, you can see here, this is just on the MEP side. Operational still ends up being the largest impact over the course of the lifespan. And then, you've got the embodied emissions up front, A1 to A3, the replacement that I talked about, and then of course the refrigerant as well, which can be large. One thing we looked at is low global warming potential refrigerants, and it made potential for a large reduction over the course of the lifespan. I've got question marks here on because these are things that are fairly uncertain. Ivan brought this up with the SIPSI process, how there's a way of, sort of guesstimating what these end of life quantities are. As I've seen, I think in their report they talked about thinking that the A1 to A3 is probably 92% of the emissions, but really we need more discussion and development of what those quantities are, and thinking about what happens at the end of life to solve our material problems. All right, so then looking at the sort of gaps in MEP. Some of these have already been touched on a little bit, but the EPDs, we really are lacking in having a good amount of EPDs to work from, which puts uncertainty in the data that we're generating. So particularly for equipment, so there's that methodology Ivan was talking about, but we're not, or if we go with one EPD, if there's one for one product, then that might really sway what's happening if you apply that to multiple other products or roughly similar products, which sometimes happens. Then we also need to better understand and quantify end-of-life impacts and how it feeds into the recycling options. For example, PV panels, what happens to them at the end of their life? Currently, some recyclers can take them in and recycle the glass and the frames, but the actual modules themselves cannot be recycled. And there's some problems there with a lot of the industry still using lead. And so what's going to happen 50 years from now when they need to be decommissioned? Then we also need some benchmarking data. We do have that study from the Carbon Leadership Forum, Oregon DEQ, which is an excellent start, but we need more. I think we need to do a better job as an industry benchmarking material quantities per system, particularly to feed into design optimization at SD and DD levels, since much of the MEP systems are not modeled at this point, and some are never modeled. For example, conduits and conductors. And so getting better data there so we can estimate it earlier on and then try to make decisions based off of that. And then we do have a lack of standardized tools such as Tally, EC3. So hopefully, in the future, some MEP elements will start to be able to be populated into EC3. But right now, we're kind of at this point where it's a little ad hoc and we're trying to develop good methodology. And with that, yeah, that's all I've got. Turn it over to David.